why do we love Saturn so much? Right, because we love its amazing rings. The planet stands out in the solar system because of them. The major rings have a diameter of 170,000 miles, yet their thickness does not exceed 330 feet. Saturn's slowest outermost ring spins at about 37,000 miles per hour. It's slower than the rotation of Saturn itself. But did you know that Saturn was ringless for most of its history? Let's find out how they were formed. Using Cassini's final plunge into the planet, researchers could estimate the ring's mass, 33 billion pounds. Further, they have determined that the rings were between 10 to 100 million years old, much younger than the planet itself. The thing is that the rings only look solid. They are made of billions of rock and ice chunks. They are primarily tiny ones, looking like grains of sugar to those as large as a house, or even as mountains. The innermost chunks of ice and rock shoot through space at about 52,000 miles per hour. There are mysterious spokes in its rings. It seems they form and disperse within a couple of hours, and these spokes might consist of electrically charged sheets of tiny particles formed when small meteors hit the rings, or maybe electron beams from Saturn's lightning. One theory says Saturn's rings have formed all that extra material that remained after Saturn began, which is a material that couldn't create a moon. There's also a theory that says there was Theia, a Mars-sized planet that collided with Earth about 4.5 billion years ago. Lighter crust parts ended up in space during the impact, whereas its denser core stayed behind. But in the case of Saturn, all that debris perhaps didn't put a new moon together, but it formed rings many people today recognize this planet for. Another theory is that rings formed from dust and debris of a moon that ended up destroyed by this big impact, maybe by an asteroid or comet. Or perhaps the rings are there because once a moon fell apart because of the tidal forces coming from its parent planet itself. If these rings formed at the same period as Saturn did, they would have had more than 4 billion years to collect a bit of debris and dirt coming from micrometeorite collisions. But these rings mainly consist of water ice, no dirt at all, which means they're younger than expected. And the nature of this ring system tells us a thing or two about Saturn's fuzzy inside. Fuzzy means its core is like sludge. The helium and hydrogen in Saturn mix with more and more rock and ice over time the closer you go to the planet's core. It's similar to what you see in our oceans. The deeper you go, the level of saltiness increases. But the rings may disappear in the far future. Rings are generally more common than we think. Jupiter, Uranus, and Neptune all have their own ring system. But not every planet has the same ones. Saturn has a fascinating halo and definitely the most spectacular rings, true. Others mostly have rings made of dust and rocky particles, and not just planets. Other space bodies can have rings, like the asteroid called Chariklo. But even though the gas giants of our solar system have rings, rocky or so-called terrestrial ones don't. And one theory says it might have been that way because gas planets in the outer area of the solar system protected those rocky ones that formed in the inner solar system from all those collisions that possibly could have formed rings around them. Or it could be because gas giants are way bigger and their enormous volume allows them to have a ring system that can remain stable. And what if Earth had rings in the past too? Maybe in the time of the big collision when our moon could have been formed. Now to some more cool things happening in our solar system. Pluto, a tiny dwarf planet at the edge of our solar system, also the one we used to call a planet, has a pretty bizarre atmosphere. No one expected to see a haze there go as high as 1,000 miles. That means it rises higher above the surface of the atmosphere of our home planet. And the atmosphere on Pluto has around 20 layers. They're more compact and way cooler than scientists expected, and tons of nitrogen gas escape Pluto by the hour. But the dwarf planet still finds a way to constantly create new supplies of all the nitrogen it had lost. One theory says it probably produces these supplies through geological activity. Our moon is pretty peaceful, but that's not something we can say for Io, one of Jupiter's moons. This one has hundreds of volcanoes. It's the moon with the most volcanic activity in our solar system. Io sends plumes of sulfur up to an incredible 190 miles into its atmosphere. Its volcanoes emit many particles and gases into the space right next to Jupiter every single second. Its eruptive activities happen because of Jupiter's mighty gravitational forces and magnetic field. The insides of Io tense up and relax all the time, depending on how close or far away it is from Jupiter. And that's why it generates enough energy to have such an eruptive nature. Speaking of volcanoes, Mars has one larger than the whole state of Hawaii. At first, you'd probably say it's a quiet and peaceful planet. But once upon a time, enormous volcanoes dominated its surface. Yup, that includes a well-known Olympus Mons, the largest volcano ever found in our entire solar system. 374 miles across, comparable to the size of Arizona. Olympus Mons is 16 miles high, 3 times the height of our tallest mountain, Mount Everest. And by its volume, this volcano is 100 times bigger than the largest one on Earth. Mars can have such big volcanoes because its gravity is significantly weaker than the one on our home planet. Also, the crust on Earth moves all the time, unlike the Martian crust. Do you know how the Hawaiian Islands formed? A hot spot in the mantle created a chain of volcanoes in the crust floating above it. A Martian volcano may grow bigger because its surface isn't moving, so a volcano could build up for a longer time in just one spot. Miranda is one of the most bizarre moons in the outer part of our solar system. It's a shadowy moon that orbits Uranus with many craters, sharp ridges, and similar disruptions on its surface. Usually, this type of relief tells a certain area used to have a lot of volcanic activities. But that wasn't the case with Miranda. Also, this moon is way too small to generate tectonic activities, another element that could form this type of surface. One theory says the gravitational force from Uranus could have caused the push-pull action, something that made all these bumps on Miranda's surface. We'll have to send another spacecraft to find out what was happening there. We are all made of stardust. 97% of atoms we're made of are the same as the material our galaxy consists of. The building blocks of life is a term we use for a group of elements that are vital for life on Earth. And stars have these elements too, but in different proportions. For instance, we are 65% oxygen by our mass, whereas elements we measure in space, like the spectra of stars, have less than 1% of oxygen. So, Mercury is already the smallest in our solar system in the planet category, excluding some other bodies like the dwarf planet Pluto. And now it looks like it's still shrinking. It's the second densest after our planet, but it's getting denser over time. Researchers thought the Earth was the only planet in our solar system with tectonic activities for a long time. And now we know Mercury is tectonically active too. Messenger spacecraft managed to map the whole planet. Scientists realized the planet is full of fault scarps, some cliff-like landforms. Since these are relatively small, they're probably young, and Mercury is still contracting even 4.5 billion years after our solar system was formed.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.